Coisson, and I'm a researcher at INRiM, the National Metrological Institute in Italy. I'm also the coordinator of the TRaMM project, where TRaMM stands for Traceability Routes for magnetic measurements. It is a training project where an expert National Metrological Institute will transfer knowledge and expertise on a certain subject to other national metrological institutes that do not have yet developed the expertise on that subject. In the case of the TRaMM project, the topic is magnetic measurements and calibrations. To name a few examples of the fields where this expertise is important, for example, you may want to measure the magnetic field in proximity of an electrical motor or of a medical equipment that is used for diagnostics. You may want to know the exposure levels to electromagnetic fields of workers or of the general population close to specific appliances. Or you may want to measure the magnetic properties of the materials that are used, for example, in electrical motors used for the electrical mobility, or the generators used in wind turbines. There are three partners in the TRaMM project. One is INRiM, the National Metrological Institute of Italy, that is the coordinator, and that is the expert partner that will transfer knowledge to the other two components of the project, that are CEM, that is the National Metrological Institute of Spain, and NSI, the one of Ireland. The main objective of the TRaMM project is to transfer knowledge from INRiM to CEM and NSI on magnetic measurements and calibrations. This will be done through a series of high-level training events, both online and in our laboratories, such as this one. But this objective is not as abstract as it may seem. Indeed, there's a strong relationship with industry and academia that make use of magnetic measurements and calibrations, indeed that need magnetic measurements and calibrations to develop new technologies or new materials to measure magnetic field or to produce power transformers, electrical motors, new technologies for the electrification and energy conversion. Society demands cleaner transportation systems, cleaner energy sources, sustainable ways of improving our lifestyle, better technologies for diagnostics and therapy. All these technologies make use of magnetic materials and magnetic measurements, but in spite of this pressure, the industry that wants to bring to the market new technologies or new materials have difficulty in assessing their performance because of the lack of adequate metrological infrastructure to measure magnetic properties and calibrate probes. This is where the TRaMM project fills in. We intend to extend the network of expert national metrological institutes in this field in order to make in the future the European industry a leader in the world in such a field of technology. Today, we know how to do magnetic measurements and calibrations in a standardized way, but on a limited class of materials and setups that have been studied intensively in the course of years. But new applications and new technologies also require new tools. For example, nowadays we have new classes of materials such as magnetic nanoparticles or 3D printed components of electrical motors that need to be characterized in standardized ways, but these standard ways have not yet been conceived. Or, for example, we have magnetic sensors that measure magnetic fields at the nanoscale, but the way to calibrate them in an absolute way has not yet been described in literature. There's not yet consensus on how to do that. So there is this pressure from the industry and the academia that pushes us in finding new ways to build a metrological infrastructure for magnetic measurements and calibration that is needed to fill the gap between what the new technologies require and what is currently available in the scientific landscape. INRiM is the project leader. This is not only a formal assignment. Indeed, INRiM has a long expertise in magnetic measurements and calibrations and is one of the very few metrological institutes in Europe having these competencies. So we will transfer this part of this knowledge to the other partners, And we hope in the future to be able to build a network of expert NMIs that will lead new initiatives such as fundamental and industrial research projects that involve this kind of knowledge.